I'll do example 1b here, a similar problem where I'm solving by substitution. And this time my system of equations is 5x minus 3y equals negative 1, x plus y equals 3. And either equation, my bottom equation, is definitely going to be easier to get one of my variables isolated, but either variable is easy enough to work with. So it really doesn't matter which variable you use. I like, in this case, getting x by itself, just because then I don't have to distribute this negative 3. And if I get x by itself here, I'd have x equals 3 minus y after I subtracted y from both sides. All right. So I take this x equals 3 minus y and substitute this in to my first equation in the place of x. So keep in mind that we always have to plug that in to the other equation, not your original, or not the one that we rearranged, I guess. So after we do that, we have 5. Instead of writing an x here, I'm going to substitute 3 minus y minus 3y equals negative 1. Distribute this 5. You get 15 minus 5y minus 3y equals negative 1. Combine my like terms, negative 5y minus 3y is negative 8y. And I want to get y by itself, so I'm going to subtract 15 from both sides. Subtracted 15 again. And now I'll divide by negative 8. So this is positive 2 here. Alright, nice. I get a whole number here for y instead of example 1a where we had the fractions. Sometimes we'll have fractions, sometimes whole numbers. Either way, be prepared for either option. I know y. I can plug this in. And just looking at my two equations here, 5x minus 3y equals negative 1, and x plus y equals 3. This bottom equation looks like it's going to be a lot easier to plug my value in. So I'm going to use this bottom equation, x plus y, but we know y is 2, equals 3. Subtract 2 from both sides, we get x equals 1. So my ordered pair is 1, 2.